Hello guys, welcome aboard. Today I'm going to be tackling this firewall fundamentals room from TryHackMe. I'm still following along the learning path from Cybersecurity 101. So I will probably make of this some kind of playlist on my channel, just for people that want to also go through these modules and maybe, um, I don't know, maybe their thing is to actually watch videos of people doing the modules to learn or something, or just to check out some little piece. But that's that. So what is the purpose of a firewall, right? This is from the section security solutions, right? Okay, so we have seen security guards outside shopping malls, yeah, banks, restaurants, and houses, right? So these guards are placed at the entrances of these areas to keep a check on people coming in or going out. The purpose of maintaining this check is to ensure nobody sneaks in without being permitted. This guard acts as a wall between this area and the visitors. A lot of incoming and outgoing traffic flows daily between our digital devices and the internet they are connected to. What if somebody sneaks in between this massive traffic without getting caught? We would also need a security guard for our digital devices then, who can check the data coming in and going out. This security guard is what we call a firewall, right? A firewall is designed to inspect the networks or digital devices incoming and outgoing traffic. The goal is the goal is the same as for the security guard sitting outside a building, not letting any unauthorized visitor enter a system or a network. You instruct the firewall by giving it rules to check against all the traffic. Anything that comes in or goes out of your device or network would face the firewall first. The firewall will allow or deny that traffic based on its maintained rules. Most firewalls today go beyond rule-based filtering and offer extra functionalities to protect your device or network from the outside world. We will discuss all these firewalls and perform practical lab demonstrations on a few. So this is the unwanted traffic that wants to go to the firewall and then it gets burned. You know, the firewall doesn't allow that unwanted traffic. Only allow traffic goes to the basically from the internet to the internet from the particular device or particular device that belongs to a network, right? Because firewalls are placed on networks. Okay, so after completing the room, you will have a basic understanding of the following areas: the types of firewalls, the firewall rules and its components, hands-on Windows built-in firewalls, hands-on Linux built-in firewalls. Okay, which security solution inspects the incoming and outgoing traffic of a device or a network? Firewall, right? Okay, types of firewalls. Firewall deployment became common in networks after organizations discovered their ability to filter harmful traffic from their systems and networks. Several different types of firewalls were introduced afterward, each serving a unique purpose. It's also important to note that different types of firewalls work on different OSI model layers. Firewalls are categorized into many types. Let's examine a few of the most common types of firewalls and their roles in the OC model: stateless firewalls, stateless inspection firewalls, proxy firewalls, and next generation firewalls. Those are the types of firewalls, right? The stateless, this type of firewall operates on layer 3 and layer 4 of the OSI model and works solely by filtering the data based on predetermined rules without taking note of the state of the previous connections. This means it will match every packet with the rules regardless of whether it is part of a legitimate connection. It maintains no information on the state of the previous connection to make decisions for future packets. Due to this, these firewalls can process the packets quickly. However, they cannot apply complex policies to the data based in its relationship with the previous connections, right? Suppose the firewall denies a few packets from a single source based on its rules. Ideally, it should drop all the future packets from this source because the previous packets could not comply with the firewall's rules. However, the firewall keeps forgetting this, and future packets from this source will be treated as new and matched by its rules again. Okay. Then stateful firewall, I would assume it's the opposite. Unlike stateless firewall, this type of firewall goes beyond filtering packets by predetermined rules. It also keeps track of previous connections and stores them in a state table. This adds another layer of security by inspecting the packets based on their history with connections. Stateful firewalls operate at layer 3 and layer 4 of the OC model. Suppose the firewall accepts a few packets from a source address based on its rules. In that case, it will take note of this connection in its stated table and allow all the future packets for this connection to automatically get allowed without inspecting each of them. Similarly, the stateful firewalls take note of the connections for which they deny a few packets, and based upon this information, they deny all the subsequent packets coming from the same source. And then is the proxy firewall. The problem with previous firewalls was their inability to inspect the contents of a packet. Proxy firewalls or application level gateways act as intermediaries between the private networks and the internet and operate on the OC model's layer 7. They inspect the content of all packets as well. The requests made by user in a network are forwarded by this proxy after inspection and masking them with their own IP address to provide anonymity for the internal IP addresses. Content filtering policies can be applied to these firewalls to allow, deny incoming and outgoing traffic based on their content. Next generation firewall. This is the most advanced type of firewall that operates from layer 3 to layer 7 of the OC model, offering deep packet inspection and other functionalities that enhance the security of incoming and outgoing traffic. It has an intrusion prevention system that blocks malicious activities in real time. It offers heuristic analysis by analyzing the patterns of attacks and blocking them instantly before reaching the network. NGFWs have SSL and TLS decryption capabilities, which inspect the packets after decrypting them and correlate the data with the threat intelligence feeds to make efficient decisions. The table below lists each firewall's characteristics, which will help you choose the most suitable firewall for different use cases. Which type of firewall maintains the state of connections? Stateful firewalls. What? Oh. Okay. So which type of firewalls offer heuristic analysis of the traffic? That would be the next generation, right? Which type of firewall inspects the traffic coming to an application? Only the traffic? Well, that's a proxy firewalls, right? What is a hint? It's also known as application level gateway. Okay, so then we come to the rules in firewalls. A firewall gives you control over your network's traffic, although it filters the traffic based on its built-in rules. Some customized rules can be defined for various networks. For example, there would be networks that want to deny all the SSH traffic coming into their network. However, your network would have a requirement to allow SSH traffic from a few specific IP addresses, right? The rules allow you to configure these customized settings for your network's incoming and outgoing traffic. The basic components of a firewall's role are described below. Source address, the machine's IP address that would originate the traffic. Destination address, the machine's IP address that would receive the data. Port, the port number for the traffic. Protocol, the protocol that would be used during the communication. Action, this defines the action that would be taken upon identifying any traffic of this particular nature. And then direction, this field defines the rule's applicability to incoming or outgoing traffic. Then comes types of actions, right? The component action from a rule indicates the steps to take after that data packet falls under the category of the defined rule. Three main actions that can be applied to a rule are explained below. Allow, deny, or forward, right? A rule's allow action indicates that the particular traffic defined inside the rule would be permitted. For example, let's create a rule with an action to allow all the outgoing traffic from our network for port 80 used for HTTP traffic for the internet. So allow any destination TCP protocol 80 outbound, right? Okay, so it's going to be allowed. And rules deny action means that the traffic defined inside the rule would be blocked and not permitted. These rules are fundamental for the security team to deny specific traffic coming from malicious IP addresses and create more rules to reduce the threat surface of the network. For example, let's create a rule with an action to deny all the incoming traffic on port 22. Okay, used for remotely connecting to a machine via SSH, right? This is to actually gain remote access to a machine. So, of our critical server or machine, right? So deny any, and this is the port, the protocol is TCP inbound, right? So forward, the action forward redirects traffic to a different network segment using the forwarding rules created on the firewall. This applies in the firewalls that provide routing functionality and act as gateways between different network segments, right? For example, let's create a rule with an action to forward all the incoming traffic on port 80 used for HTTP traffic to the web server 192.168.1.8. Okay, so that's going to be the destination. So you're going to be forwarding that traffic to this particular IP port 80, all the inbound, right? So from any source. Okay. Directionality of rules. Firewalls have different categories of rules, each categorized based on the traffic directionality on which the rules are created. Let's examine each of these directionalities, right? So inbound rules, outbound rules, and forward rules. This kind of is the same as before, right? Inbound rules are categorized into inbound rules when they are meant to be applied to incoming traffic only. For example, you might allow incoming HTTP traffic on port 80 on your web server, right? Which is the case. Outbound rules. These rules are made for outgoing traffic only. For example, blocking all outgoing SMTP traffic port 25 from all devices except the mail server, right? That makes sense. Forward rules. Forward rules are created to forward specific traffic inside the network. For example, a forwarding rule can be created to forward the incoming HTTP port 80 traffic to the web server located in your network. So which type of action should be defined in a rule to permit any traffic? Allow. And then what is the direction of the rule that is created for the traffic leaving our network? Outbound. Come on, what's up? Okay, let's move on. Let's start this machine. What happened? Okay, now you take into consideration my response. Okay. Okay, so let's start the virtual machine by pressing the Start Machine button given below. The machine will start in a split view. In case the VM is not visible, use the show split, blah, blah, blah. Okay, this is a Windows machine, so we'll probably be connecting to it using Remina or RDP. But, I mean, yeah, it just depends on how long it takes to boot up. Windows Defender Firewall. Windows Defender is is a built-in firewall introduced by Microsoft in the Windows OS. This firewall contains all the basic functionality for creating, allowing, or denying specific programs or creating customized rules. This task is designed to cover some of the essential components of the Windows Defender firewall, which you can utilize to restrict your system's incoming and outgoing network traffic. To open this firewall, you have to open the Windows and search and type Windows Defender Firewall. The Windows Defender Firewall's homepage shows the network profiles and the available options. This is the main dashboard with all the options for the firewall. Network profiles. So there are two available network profiles. Okay. Windows Firewalls determines your current network based on network location awareness. NLA and applies that profiles firewall settings for you. We can have different firewall settings for each of them. Okay, private networks. This includes the firewall configuration to apply when connected to our home network. Guest or public networks. This includes the firewall configuration to apply when connected to a public or untrusted network like coffee shops, restaurants, or similar. For example, when connecting to public networks, you can configure firewall settings to block all incoming network connections and allow only some outgoing connections that are essential for you. These settings will apply to the public network profile and will not be implemented when you are in your private home network. So to allow or disallow any application in any of your network profiles, click on the option highlighted, one in description, control panel home. Okay, this will take you to the page listing all the apps and features installed on your system. You can check mark the ones you want to allow in any of your network profiles or uncheck those if not needed. Windows Defender Firewall is turned on by default. However, if you want to turn it off, or you can click on the option highlighted on number 2, turn off, right? This will take you to the setting for both of your network profiles rather than completely turning it off, which Microsoft doesn't recommend, right? You can also block all incoming connections. You can also click on Restore Defaults, highlighted as 3, in the screenshot from the main dashboard anytime to restore all the firewall's default settings. Okay, now we get to the custom roles. Windows Defender Firewall also allows you to create custom rules for your network to allow or disallow specific traffic as needed. Let's create a custom rule to block all outgoing traffic on HTTP port 80 or HTTPS port 443. After creating this rule, we will be unable to browse any website on the internet as the websites are working on port 80 or port 443 for HTTPS, right? Which we will be blocking. So before creating this rule, let's test if we are able to visit a website. For testing, let's visit this particular website. As shown in the screenshot below, we are able to visit the website. Yes, connection verified. Okay, to create a custom rule, choose advanced settings from the available options in the main dashboard. So that would be those firewall. We go to control panel, then we go to system and security, and then we go to Windows Defender Firewall. Okay, and now we're able to see control panel. Okay, that's it. Okay, so the first thing we have to do is the rule created, you can see the available options. So to create a custom rule, choose advanced settings from the available options in the main dashboard, which is this one. This will open a new tab where you can create your own rules. Okay, the rule created below is already available inside the attached VM. If you want to test it, you can create it in your own Windows host machine or any other machine. Okay, you can see the available options to create inbound and outbound rules. Okay. Yeah, inbound rules and outbound rules, right? Okay, let's create an outbound rule. Okay, let's go here, then new rule, I would assume. Yeah, then click on new rule on the right side. It will open the rule wizard in the first step, select the custom option and press next. Okay, in the second step, select all programs from the next option and then press next. It will ask you to select the protocol type in the third step. Select the protocol type as TCP. Okay. Keep the local port as it is and change the remote port to specific ports. Okay. From the drop down, write the port number in the field below, in your case 80 and 443. Okay, 80. Okay, now click on next. No, separate the port number by commas and please don't leave spaces between them. Okay, let's go back. They did say no spaces. But the example has spaces, as far as I can tell, but well. Okay. Then in the scope tab, keep the local IP and the local and remote IP addresses as they are. Okay. And press the next button. In the action tab, enable the block the connection option and press enter. Yes. And press next, I'm sorry. Okay. In the profile tab, which is where we are right now, we keep all the network profiles check marked. Lastly, the final phase is to give your rule a name and an optional description and press the finish button. Okay, we'll keep this as it is. We can see our rule is there in the available outbound rules. Okay, so the name we're gonna give it is block HTTP and HTTPS traffic finish. Okay, we can see our rule here, newly created rule. Now let's test our rule by browsing to HTTP and this. We get an error message. Saying, okay, but hold on. I guess that would apply only if we access from this one, although I think this is, am I correct? Content from the website listed below is being blocked by the Internet Explorer and security. Okay, close. Can't reach this page, right? So exercise. The security team noticed suspicious incoming and outgoing traffic on their critical Windows system. They created rules under Windows Defender Firewalls to block some of their specific network traffic. You're tasked to answer a few questions given at the end of this task by looking at the created rules. Okay, let's close this. These are the outbound and inbound rules that have been created. So what is the name of the rule that was created to block all incoming traffic on the SSH port? So we are okay, blocking incoming, which means inbound, and then we want to filter this, right? Can we filter them by date? So if it's going to be on the SSH port, I would guess filter by profile. Okay, no. What is the name of the rule that was created to block all incoming traffic on the SSH port? General programs and services, protocols and ports. Okay, specific port 22. Programs. I would guess then that this is the one that they have created to block incoming traffic on the SSH port. Our rule was created to allow SSH from one single IP address. From one single IP address. Infra team, for only the infra team maybe. Okay, specific ports, TCP. Okay, scope, any IP address. Oh, okay, remote IP address is only this one. From one single IP address, and that's this one. So we are gonna be infra team, right? This is the name of this rule. Which IP address is allowed under this rule? Well, the IP address that is allowed is this one that I'm seeing right now, 192.168.13.7. Okay. And the last one, Linux iptables firewall. Okay, in the previous task we discussed the built-in firewall available on the Windows OS. What if you're a Linux user, which is my case? You still need control over your network traffic. Linux also offers the functionality of a built-in firewall. We have multiple firewall options available here. Let's briefly review most of them and explore one of them in detail. NetFilter. NetFilter is the framework inside the Linux OS with core firewall functionalities, including packet filtering, NAT, and connection tracking. This framework serves as the foundation for various firewall utilities available in Linux to control network traffic. Some common firewall utilities that utilize this framework are listed below. iptables. This is the most widely used utility in many Linux distributions. It uses the NetFilter framework that provides various functionalities to control network traffic. And ftables. It is a successor to the iptables utility with enhanced packet filtering and NAT capabilities. It is also based on the NetFilter framework. Firewall, WALD. Okay, this utility also operates on the NetFilter framework, and has predefined rule sets. It works differently from the others and comes with different pre-built network zone configurations. UFW, which is the one I've previously used, it's an uncomplicated firewall. As the name says, eliminates the complications of making rules in a complex syntax in iptables or its successor. By giving you an easier interface. It is more beginner friendly. Basically, whatever rules you need in iptables, you can define them with some easy commands via UFW, which would then be configuring your desired rules in iptables. Let's have a look at some basic UFW commands down below. To check the status of the firewall, you could use the command below, sudo UFW status. Let's check the status of my firewall on my main computer. Inactive. Solid. As it appears inactive, you can enable it using the following command. To turn off the firewall, type disable instead of enable in the above command. Okay, makes sense. Below is a rule created to allow all the outgoing traffic connections from a Linux machine. The default, what? To allow all the outgoing connections from a Linux machine. Okay. So the default in the command means that we are defining this policy as a default policy, allowing all the outgoing traffic unless we define an outgoing traffic restriction on any specific application in a separate rule. You can also make a rule to allow denied traffic coming into your machine by replacing outgoing with incoming in the following command. Sudo UFW default allow outgoing. So allow all default traffic, right? You can deny incoming traffic at any port in your system. Let's say that we want to block incoming SSH traffic. We can achieve this with the command UFW deny 22 TCP. As you can see, we first specify the action deny. Furthermore, we specify the port and the transport protocol, right? TCP, which is TCP port 22, or simply 22/TCP. Okay, makes sense. To list down all the active rules in a numbered order, you can use the following command. Okay, to delete any rule, execute the following command with the rule number to delete. Okay. These different utilities can be used to manage NetFilter. Choosing the right utility for the Linux OS depends on multiple factors, such as familiarity with the OS and your requirements. You can test your knowledge of Linux firewalls by creating some rules defined in this task and testing them to ensure they are working as expected. Okay. Which Linux firewall utility is considered to be successor of iptables? Uh, I think you mentioned this here. And iptables, right? What rule would you issue with UFW to deny all outgoing traffic from your machine as a default policy? Answer without sudo. Okay, it would be something like this. Okay, and we got it, right? We finished this room. This was the firewall fundamentals room. And that was it with me, guys. Okay, I'll see you in the next video, guys. Thanks for staying tuned.